Welcome back to the KB Data Science channel. Today is Tuesday, January 5th, 2021. I'm going to take a second, or actually a third look at the Swedish data, just to see if we can really get a better handle on what's really going on. A spoiler alert, the problem is related to that they're only recording numbers Tuesday through Friday now rather than 7 days a week. So what you're going to see is you're going to see that the cases and deaths for Sunday, Monday, Saturday, Sunday, Monday are added on to Tuesdays. So you're going to see the spike on Tuesdays. Then you're going to see the cases and deaths drop back down for the next 3 days. Okay, I'm going to be doing something a little different today. First of all, I'm going to show you the data here. You come over here, it says coronavirus updates, read more. Come down here, click here. This is GitHub. I'll put the link to this in the description below. Okay. And there's two ways you can get this data, all right? You can use GitHub and clone the data, which allows you to clone it every day. But by the way, if you use GitHub like this, you cannot make changes to this data. Okay, very important. Or you can download the whole thing as a zip file. I use GitHub because it allows me to update my data every single day without any problem. Okay. Well, by the way, ourworldindata.org actually has a lot of online data visualization for many different issues and not just COVID-19. Okay. So now we got some data. All right. Now I'm going to be using a tool called Falcon SQL Client. This is a data visualization tool that's built on top of Plotly, and by SQL, you can basically run this SQL client with any data you want to. You can use it with any database software you want to. You can also use it with a straight text file. So let's do that. So let's see if we can find a link to this also. I'll put a link to the Falcon SQL client also. You can see none of this stuff has been updated here so far. Okay. Okay. You can come over here. Okay. And download the Falcon SQL app. All right. So we've already got our data here. Let's try something a little different. Normally I'm using a database like SQLite. It makes it much easier to do queries on it, but you actually don't have to do. You can actually do queries with the CVS file. So let's take a CVS here. Okay, the problem with this is always that the view function doesn't work. What am I looking for here? Our world in data, public data. And all I got to do is come over here and drag this up to there. Okay? We're going to connect. We're connected, so we come over here. And you can see it doesn't actually identify the numbers here. Now, I'm because it doesn't actually have a name for the data table at this point. We can still do this where let's do location. Location. Let's try this now. Okay, we should be able to do this. Oh, here. So now we only got the data for Sweden. Let's start with a quick plot here, first of all. We're going to use this. So we're going to plot date. Then we're going to plot new cases. Take a look what's going on here. This curve back here is fairly smooth, but this up here, this is the Tuesday date. Then it comes down, and it gets the other dates. Let's do more things. Let's place a some type of smooth curve on top of here. Okay. So this is a smooth function. I'm not really sure, but you see if you do something like but you can see what's plotted 1, 2, 3, 4. Tuesday, Wednesday, Thursday, Friday. So this is if you see this report, be cautious. Okay, be careful. All right, because this by itself can really be used to mislead the people, and I'm sure it is being used. If your media is like anyone in the media in the United States, I can guarantee you that you're being misled with this data here. Okay, let's get rid of the daily data and look at this curve here. Look how smooth this is once we cut through the underlying numbers. Let's do this. New cases per million. See, this number by itself isn't very good. There's lots and lots of code here, data here, but it doesn't really serve us much good. Okay, here we go. You know, look at the difference between this section here and this here. But these spikes really distort this number here, okay? And that's the problem. It really distorts the numbers, right? Do a transform. Okay. All of a sudden, you got these massive volatilities. So it's back in August when this actually started. All right. If we zoom in on cases, we're basically going to see the same thing. December 2nd, December 6th. Okay? So let's change to a slightly different style plot. Let's change to a and this looks more like what you're seeing on the other side over there, but you're not seeing this. So they must be doing something wrong or different. Let's see. Do we have weekly total for cases? No. Okay, let's come back over here. Connection. Let's come back over here. And let's take a look. Okay. Let's do this. Let's do a number for Johns Hopkins. Full data. The reason I'm going to do this is because the full data function, okay, has a biweekly figure. Save changes. Connecting. Okay. Once again, you see the number here. Let's run this again. Okay. What you see here, you see new cases. These are daily cases. Total cases are cumulative cases. Now here's where it gets fun. The weekly numbers. The first question is, where, what is their week? Do they add Saturday and Sunday and Monday onto Tuesday's numbers, or do they add it on to Friday? Do they add it on to the end? Okay, let's go do some basic charts. You know what? Let's do. Let's get a little tricky. Let's go ahead and upload this thing here. This is the same thing, but it's a more. You can see we went from a desktop app to a website. Okay, so let's start once again. Choose this date. Let's take a look at new cases. So you can see here what's really going on. Okay, let's add on top of that date and weekly cases. You can see the difference here. Obviously, my guess is what they're doing is that they are calculating. So this is a total for each week. It's not a moving average. Okay, it's a total for each week. All right. So they must be publishing weekly totals in that case. All right. And if you look down there, you can see the blue lines here. Now, but the problem is this here. This isn't really necessarily that good because you're still seeing over 50,000 cases in a single day here. Okay, that's the problem. Let's take a look at a smooth number instead. Oh, so we don't have a smooth number, do we? Okay, let's do this then. Analyze, transform. What we're looking for is a moving average. All right. Okay. Traces. Let's change this to line. All right. Now let's come down here to analyze. Moving averages. Trace one. Let's come down here to 14. Let's do a 7-day moving average. And we're going to go centrals. Okay. Let's zoom down here now. So this end date is June 1st, 2021. What we're doing here is we took the previous 7 days and did an average of them. All right. And I'm guessing you don't actually you didn't actually have 30,000 plus cases in a single day. This is the total for those 3 days. Okay, 4 days. This is the total from Fridays to Tuesday, or from Sunday to Tuesday's numbers. All right, and that's the problem. You see, that's the problem with this data. Let's take a look at deaths. Okay, same thing. You can, look how nice and smooth this looks here. Now look how nice and smooth these deaths look over here. Did you really have 243 deaths on a single day? Well, that's kind of strange, isn't it? Okay. This is a 7-day moving average. On all probability, you probably actually only had maybe 75. You probably only had maybe, I'm going to be generous, say 100 deaths here. That's the number of deaths you're averaging per day. Okay. So that's this number here is a number of deaths for the previous 3 days, and this is the 7-day average it does. Okay, so this is probably going to be Monday to Sunday maybe, or Sunday to Saturday. I'm not quite sure, but here's the problem remains the same here, of course. Okay, so that's really what I wanted you to see here. You have to understand the numbers that you're looking at. Okay, let's take a look at biweekly cases. So these are the total number of cases for each 2-week period. Okay, these are total cases. Did you really have 80,000 cases in one day? No, you didn't. But you can see the smoothing effect here anyway. Let's take a look at biweekly deaths. The shape's the same, but because these are totaled so these are total deaths for these are 2 weeks. These are totals for 2 weeks. Okay, you can still see the thing that's interesting is I want you to notice that the spike here on December 22nd was less than the spike here on 2019. So using a smooth average or weekly numbers really gives us a much better picture of what's really going on with the numbers in Sweden right now. Okay, don't be misled by the news media and your politicians. You need to dig into the numbers yourself. Okay, you need to dig into you can see what I've done here is very simple. You could have done the same thing with a spreadsheet program like LibreOffice Calc or Excel. All the plots here you can do these are very straightforward plots, all right, to do in Excel. But you have to use some type of cumulative total or average number or moving average or something in order to get a better understanding of what's really going on. All right. All you looked at was the daily deaths, and you didn't realize that you switched the reporting method. You say, "Oh my gosh, we had 243 deaths on December 30th." No, that's 243 deaths from Saturday to Tuesday. From Saturday to Tuesday. Okay, this is a total between Saturday, Sunday, Monday, and Tuesday. You had a total of 243 deaths. Well, this is very misleading because you got the zeros down here. No, why did he change this? I don't know. It makes absolutely no sense. And that's, of course, the only thing, maybe he didn't want to pay the overtime to people coming on Saturday, Sunday, and Monday and do this work. On the other hand, uh, can't you, when you come in on Tuesday, can't you enter these numbers for the date? Can't you enter the correct date for these numbers? Anyway, so I hope gives you a little better understanding of what's really going on here, okay? But again, you know, this, you know, this doesn't look, this doesn't look right here, okay? All right. So obviously, again, this is straight now, but they're obviously doing something. My guess is what they're doing is is they're using some type of weekly numbers. Okay. Okay, because this looks very similar, but except you didn't have 600 deaths in a day back. So each one of these columns represent a week's worth of data. So for this week here, you had a total of four for the week of December 31st, 2020. You had 448 cases. Okay. Now, if you divide it by 3, what do you get? 110, 120 cases, deaths per day. That's a big difference. That's a big difference. And in many cases, a weekly total is a much better number. Okay. But again, now these are 2 weeks worth of data in one bottom. So each column now contains 2 weeks worth of data. But it doesn't. But the thing that's still interesting is look how much lower this is. But here, my friends, this may not be great news, but it is good news. Okay, let's look at biweekly cases. Okay, again, each one of these columns is a week's worth of data. So for the week of January 4, 2021, you had 70 cases total. For the week of December 30th, 2020, you had 88 cases. Okay? Or 88 deaths. So I'm hoping this will explain things again a little more. Okay? And also give you a heads up to be careful with the numbers that you're watching. Because what I can see on the web page, they don't actually explain the plots any place. I could be wrong, it could be there someplace, but you don't really, they say daily cases, but clearly the cases aren't daily. Okay? Otherwise, you would have these gaps in there. All right? That's what I want you to understand. But the main thing is this: it appeared that you had a slight decrease here and a slight decrease here. Okay? So anyway, thanks so much for spending a few moments of your time with today. And we'll catch you another day or two with a new updated COVID-19 analysis for Sweden. Thanks so much.